Certainly early career, that technical precision and curiosity. The discipline of engineering, drawing, accuracy and clarity of standards underpins everything that comes later. Mid-career, I suppose, systems thinking and adaptability. I worked across a whole range of disciplines. I started as a mechanical engineer. Now we're building schools and everything in between, petrochem, oil and gas, power. So working across sectors and geographies means that you can't rely on what necessarily worked last time. You have to understand the system you're working with and adapt your approach accordingly. So now, I suppose, I suppose in that leadership stage, the ability to translate between technical and strategic language is important. The most important conversations in digital engineering happen in boardrooms, not server rooms. You have to be able to explain why a CDE matters and what that acronym actually means. So common data environment, why ISO 19650 compliance is an organizational capability investment in terms that resonate with people whose primary concern is delivery of outcomes, budget and risk. So throughout, I suppose, in that sort of intellectual honesty, digital engineering is a field where there's still enormous viability, variability in practice quality. The most valuable thing you can offer a client is honest assessment, even when that means identifying gaps in their own processes and standards.
Hi, just a quick one. If you're enjoying the podcast, don't forget to subscribe or follow us on your favorite podcast app or on YouTube. It really helps us share practical knowledge with more people. And if you want deeper insight, you can also subscribe to our newsletter at digitalconstructionpodcast.com. All right, let's jump in. Hi, John. Welcome to the Digital Construction Podcast. In this episode, we sit down with John Benstead. He's a digital engineering manager at School Infrastructure New South Wales, but he previously worked at NDY, Autodesk, WSP. So John has seen so many aspects of this industry, of the digital construction industry. And we will explore how digital engineering is transforming public infrastructure delivery. John is about to share insights from a global career, and it will explain how School Infrastructure New South Wales is using innovation and standardization to deliver better outcomes for the community. But before we start, John, I have a quick question for you. What's the best piece of advice you have ever received in your career?
Yeah, I did do a bit of research on this one because I do remember working many years ago. One of the very early pieces of advice was understand the problem before you propose the solution. Don't go straight to the solution. It's kind of like the old adage of measure twice, cut once. So really understand the problem before. So, I mean, it sounds too simple, but in a career that sort of spanned multiple areas, GIS, CAD, BIM, digital twins, now we're onto AI. The principle is that constant compass. Whether I was implementing, if I go back to the GIS implementation, I-21 in Europe, a mega project, and now today writing information requirements for delivery of public schools. The first obligation is always to understand the client. So for me, it's the stakeholders within SI and Department of Education, understanding and primarily asset management. So in digital engineering and BIM translates directly a PIR that nobody reads, project information requirements, PIR, or a BIM model delivered at the wrong level of information need is not a solution, it's a deliverable. So really understanding the problem means asking who will use the models, who will use the data, more importantly, for what decision and what point in the asset life cycle is it required.
And I think this is very valuable advice, because probably the people that work in this industry, like us, we are all wired to solve problems. So we just want to jump into solving the problem. And You're right. You need to hold your breath, wait a second, make sure you're solving the right problem before you go and you go ahead.
Exactly.
Very good point. And John, your career has been quite long. You've been working in this industry for more than 35 years, and you've seen it all. You've seen CAD, you've seen GIS, BIM, information management. But I just want to know, what drew you into this job, into this industry, and how did your career evolve from that point when you joined?
Yeah, well, I suppose just prior to that, I mean, I first started as a toolmaker. I did a toolmaking apprenticeship in the UK. Started work in 1978, so it kind of gives away a bit. Oh. But as a toolmaker, you work into tolerances that demand, absolute accuracy, and that discipline has never left. Certainly never left me. It's been the same mindset that I bring to information management today. Information can be absolutely accurate, even if you're going as simple as filling in a parameter with a piece of text, making sure that text is exactly what you want, locking it down to a particular standard. From toolmaking, I moved into the design office on a drawing board. So before CAD even came into it, but I was working for a company that was one of the first to implement CAD in the early 1980s, and that is what ignited that lifelong fascination with computers and what computers could do for engineering. In the mid 1990s, I'd migrated up to managing CAD departments and multidisciplinary design teams across the UK, contracts in Saudi Arabia, Tajikistan. And then in 1999, I joined Alcatel, and I was fortunate enough to get on what was one of the largest implementations of then CAD and GIS on the I-21 Pan-European fibre optic cable network, which was 18,000 kilometres of fibre optic cable across 9 countries throughout Europe. So that was building that, at that time, probably the most advanced GIS operations in Europe at that time. I then moved to New Zealand, 7 years in New Zealand, in 17 years in Australia now. And that brought me into that sort of BIM era. As you mentioned earlier, Parsons, Brinckerhoff, Norman Disney Young, some time at Autodesk. 9 years at NDY, leading BIM management across projects like Snowy Hydro 2.0, Barangaroo South, one of the first projects I worked on there, a number of international data centres, and various high-rise commercial, linear infrastructure projects in rail, etc., and working with transport. And yeah, in 2021, I've now been nearly 5 years now in the sort of government client role at school infrastructure. And that shift from, I suppose, in that consultant area to the client fundamentally changed how I think about the purpose of digital engineering now, because this is a different. There's that difference in the role, being client side, but also being government and working within the government framework, delivering assets to the public.
Yeah, that's really fascinating career, and we'll talk about these topics related to private sector versus public sector. But you also mentioned that you worked in multiple different countries, which is also really great to see. How do you think that this experience of working in different countries shaped your approach to this discipline?
I think it certainly taught me that the technology is almost never the barrier. The software will do what it's been designed to do. And yeah, we know that there might be issues with software and the like, but it's all about the human factors, process adoption, cultural change, language barriers. those different regulatory regimes, different contractual frameworks across multiple countries. Those are the real sort of implementation challenges. And on the I-21 project, I particularly pulled that one out. I worked in France, Germany, Italy, Spain, Austria, Switzerland, the Netherlands, Belgium, and the UK. And I spent a lot of time in those countries working with some really good people. It was the effort was certainly a huge team. But the idea was to develop CAD and GIS standards that worked across those 9 countries, with those teams simultaneously working. So you learn very quickly that standards only work if the people you need who need to use them understand why they exist, and they've been directly involved in developing those standards. So I didn't develop them on my own. It was a huge stakeholder engagement exercise across those 9 countries. So that experience really shaped how I approach SIDE standards today. We're not just writing technical documents, we're designing workflows. The real project teams, many still in their early digital, I suppose, maturity journey, need to be able to follow. So, and I was talking about this at another engagement recently, that it's that the technical documents that become the design workflows that generate the capability, and so the people are following a workflow, which is also then teaching them how we actually and why we need the information that we need. So the stakeholder engagement is important. It's just as important as that technical capability.
And in your career, you have seen a major transition, which was the transition from CAD to BIM, even if many may say that they still use CAD. But there was a general transition in this industry, right? And I feel that probably the current generation is potentially feeling maybe a bit concerned about the potential transition we may be facing now from BIM to who knows what AI is going to bring to the table, right? But thinking about what happened in the past, and what are the most important lessons that you've learned from the transition from CAD to BIM?
Yeah, I think I suppose that what I do regard as the important lesson, that BIM was never really about a 3-dimensional model. Even before BIM, we were using applications that were 3-dimensional, and so the transition was going from a 3D CAD application, what was interpreted as a CAD application, to a 3D BIM application. So it was always about the information, structured, reliable, sort of purposeful information, but it was never really adopted for that in those early days of BIM. We probably spent the first decade or so whilst I was in New Zealand and then Australia, really largely focused on the geometry, managing and growing model sizes with too much detail and sometimes not enough, and arguments over LOD, etc. The wrong conversation topics, but applicable at that time because we struggled with the hardware keeping up with the models. The right conversation now, which is ISO 19650 and its predecessor, PAS 1192, and more recently the New South Wales Information and Digitalisation Data Policy, Infrastructure Digitalisation and Data Policy, which are now sort of kind of forcing us into the information, thinking about what information we need, when do we need it, and in what format, and who is responsible for delivering it. Certainly not new concepts now, but remain a challenge. The shift from CAD manager to information manager is fundamentally a shift in thinking. CAD is about drawings, files, deliverables. Information management is about outcomes, decisions that are enabled, assets that are operated, and costs that are avoided. That reframe is still underway across much of the industry, and accelerating it is central to what I do at SI.
And looking back to your career and history and your past, like what skills or mindset have mattered the most at each stage of your career?
Certainly early career, technical precision and curiosity. The discipline of engineering drawing, accuracy and clarity of standards underpins everything that comes later. Mid-career, I suppose, systems thinking and adaptability. I worked across a whole range of disciplines. I started as a mechanical engineer. Now we're building schools and everything in between, petrochem, oil and gas, power. So working across sectors and geographies means that you can't rely on what necessarily worked last time. You have to understand the system you're working with and adapt your approach accordingly. So now, I suppose, I suppose in that leadership stage, the ability to translate between technical and strategic language is important. The most important conversations in digital engineering happen in boardrooms, not server rooms. It's you have to be able to explain why a CDE matters and what that acronym actually means. So common data environment, why ISO 19650 compliance is an organisational capability investment in terms that resonate with people whose primary concern is delivery of outcomes, budget and risk. So throughout, I suppose, in that sort of intellectual honesty, digital engineering is a field where there's still enormous viability, variability in practice quality. The most valuable thing you can offer a client is honest assessment, even when that means identifying gaps in their own processes and standards. So, yeah.
Yeah, definitely. It varies along your journey during your career. And at the moment, you work with School Infrastructure New South Wales. So New South Wales is a state in Australia, for those who are not familiar with what it is. Yep. But you're delivering in schools, like actual physical buildings that are schools. Yep. Can you share with us what School Infrastructure New South Wales is?
Yeah, sure. So, SI is the New South Wales government agency responsible for planning, delivering, maintaining and managing the state's public school infrastructure. It operates within the Department of Education. So, we're part of that whole infrastructure, including the teachers and the support staff that deliver the education. It's one of the largest public infrastructure delivery programs in Australia. SI delivers new schools, major upgrades, maintenance works, community accessible outdoor facilities across more than 2,200 schools across the state. And current numbers, we're serving approximately 800,000 students at this current time, in excess of that. So the scale and diversity of this program, from purpose-built high schools in the likes of Western Sydney growth corridors to small rural primary schools, is extraordinary. It's hugely variable. What makes SI significant from a digital engineering perspective is that it's simultaneously a major capital works client. It's a long-term asset owner and operator, and a direct service deliverer to the communities. So that combination means, information created during design construction has a genuine operational value. It doesn't just sit in an archive after handover. So it's all about the information and structured information.
Yeah, it's really interesting. And what challenges come with delivering infrastructure at this scale and also public importance?
I suppose the challenge is, schools are unique in that sort of public infrastructure landscape. They're genuinely multi-generational community assets. A school built today will serve 3 or 4 generations of students. The outdoor facilities are often the primary open space available to the surrounding community. But I suppose it's that variance across the state, the different areas, different environmental impacts that challenge us all the time, flood impacts, fire impacts, etc., that then cause those emergency services, and then the resultant rebuilds of our infrastructure. So that's certainly a challenge. SI work addresses that. There's two significant equity challenges in New South Wales. First of all, that puts sort of population growth. We mentioned Western Sydney at demand for educational facilities, etc. And secondly, that for facility quality. And that's something that you soon become very proud of, certainly from my perspective. When you look at the schools that we deliver, the quality of the buildings, the quality of the learning spaces. I remember when I went to school, and kind of wish I was going to school now. So that's really a bonus to be able to see that. We utilise MMC and DFMA. I know that's an interesting subject for a lot of people. We accelerate delivery. So another big challenge is when can we get into like an existing school, for instance, and redevelop that, expand it. The majority of our projects are on existing schools, so we have a window of opportunity. Based on school holidays, that type of thing. So delivery methodologies like DFMA, MMC approaches, that gives us that reduction on site time. That construction significantly reduce that on-site time. And so it's not just a cost efficiency, but as I've said, it's a means that we can disrupt minimally during construction. And digital engineering underpins all of this. So, accurate, structured information enables better life cycle planning, more responsive maintenance, and ultimately more reliable facilities for the students. So, significant challenges there, but we're certainly rising to those challenges.
Definitely, and you touched on this before. You mentioned that New South Wales is an owner and also an operator of these buildings, right? Mm-hmm. So probably there is an opportunity to bring extra value, but from your point of view, how do digital processes help ensure long-term values for students and communities?
Well, I think that's one of the challenges that comes with the delivering infrastructure at this scale and at this level of public importance. It's SI manages that program spanning multiple new school developments and redevelopments. Standardisation is our response. So through the Education Facility Standards and Guidelines, the EFSG, and our pattern book, digital content, and that standard design library, and a SIDE and BIM suite of standards. They're all interlocking, integrated documentation standards and templates for standardized design. So we've, if you like, given a springboard to design where we've already done the design, the early stage design for schools, and that's what the pattern book is. So our delivery partners can access that material, and they know that they're working from a base point which has been designed in accordance with the EFSG. Other challenges is there's also the challenge of the government procurement and approval environment, public accountability requirements, value for money frameworks, that sort of thing. Multi-stakeholder governance means decisions that a private developer might make in a matter of weeks may take the same in months. But they're a requirement. In government, it's a big eye-opener to understand that you're spending public money and you want to get the most efficient delivery from that. But it's amazing to see the quality of the schools that we put in place for considerably less money and time on site using DFMA and modern methods of construction.
And to expand on the difference, you said that sometimes a decision that in a private sector could be taken in a week, and in the public sector could be potentially months. But there are probably also other differences, like you could think of, and difference in incentives and how people make decisions and the different risks involved. But from your point of view, how does working for a government entity differs from working in consultancy or even like companies like Autodesk?
Yeah, I don't think there's necessarily that much difference. I suppose we've got an advantage in that we've been able to spend, since I joined SI in the 5 years, working across the various initiatives that we have engaged in. We've been able to pre-design, we've been able to prove the education facilities designs. So we produce that pattern book content with that intention, as that we know we're delivering to what our educators need and what the students need. So that gives us that bit of a significant shortcut into what we're actually designing and de-risking them as well. So that's significant. Our standards are in response to those requirements, and that's why it's really where we are now. We're certainly at the pivotal stage now where we've got the EFSG program, our standards, and the pattern book content really well aligned now. And next, we certainly the plan over the next few years is to really bring that full content available for our supply chain to use.
And sometimes like people work in this industry, they may be working in a company that could be serving a client that is in the public sector or could be in the private sector. So what changes when the client is public versus a private organization?
Well, as I mentioned, as far as the whole procurement approval process is concerned, that's a different environment that we work in. When I talk about the private developer maybe making that decision in a week or so, that's probably erring on a bit of a short-term time frame for them, because it can obviously take a lot longer than that. But just by comparison, the time takes longer. It takes more scrutiny, more levels of governance and approvals to go through. You have to be completely transparent in what we do, and that's natural when you're spending public money. So that is the biggest difference between working in that sort of commercial environment and working in the public, that public accountability environment.
And I speak with many people that work in the private sector, and often they say we like the government to produce standards, or they want to unify standards. And sometimes they blame the government, right? So they say, oh, the government should do something about it. But how does the government influence industry standards and potentially behavior?
Oh, it does, and I think we're getting to that now. And I've just this week we've been involved in meetings with Infrastructure New South Wales, who've recently released the Infrastructure Digitalisation and Data Policy. That's a significant document, and it's not a document that's difficult to read or understand, because it's common sense. So we're already well aligned with that policy, but it also gives us an opportunity to, along with other government agencies, because that policy document was primarily contributed to by all government agencies. So we are closer to that. There are differences between each government agency. My requirements, whilst there are similarities with transport and Department of Health, then the way we do things is pretty much identical as far as what the importance for us is information and is managing assets. So there's those similarities, but they're very different deliverables. How's a school's completely different from a hospital. completely different to the rail network. But there is significant areas that we can align, and so those standards are there. So you will see those standards being released individually by the agencies, but you'll see the fundamentals behind them being the same. ISO 19650 classification requirements, working within a common data environment, structured data, producing structured data, and we're aligning those data requirements as well across agencies. So there's opportunities for us there. So you'll see that grow.
And for anyone looking to move from maybe the private sector to the public sector, do you think that there are different type of skills that are essential for somebody who wants to make this move from private to public?
I suppose the most critical skill is contextual intelligence. Let's put it that way. The ability to rapidly understand the sort of incentive structures, risk frameworks, and decision-making cultures of the environment that you're working in, to adapt your communication approach accordingly. If you think about it, you come from the commercial environment, private developer, whatever it might be, and you literally are needed to work in a completely different environment. So you need to be able to change. So if you've got change is inevitable. That is the biggest change, I suppose, going from public between public and private sectors. Technical skills transfer directly. So cultural skills require deliberate recalibration. So technically, you're okay. Culturally, you've got to recalibrate. In private practice, pace and decisiveness are great, are valued. In government, thoroughness, consultation, accountability, documentation are equally important. So, neither approach is wrong. They serve different governance requirements. So that, I'll go to that again. So private practice, pace and decisiveness are valued. So rapid movement, government, thoroughness, consultation, accountability, documentation are equally important. The skill I'd most recommend developing for a sector transition is stakeholder management at the sort of political and executive level. In consultancy, your most important stakeholder is typically your client project manager. In government, the landscape is vastly more complex, and I'm still learning it, and I've been here 5 years. Ministers, directors, Director General, Treasury, the Audit Office, etc., industry bodies, community groups, and navigating it all effectively requires genuine political intelligence, not just technical competence. So, yeah,
definitely. And in your role, you're probably able to see a lot of innovation in digital. And I was wondering what innovation is your digital engineering team currently driving at School Infrastructure New South Wales. If there is anything you can share with us.
Yeah, I think any digital engineers, they're always interested in where they can sort of push the boundaries, what latest tech is available, and particularly now with the advent of AI. I suppose our current innovation agenda sits across 3 interconnected areas. That's sort of standardisation, automation, and integration. So I won't mention AI just yet. And just talk about that. Standardisation, we've been undertaking a sort of a comprehensive review of our own standards, our SI, DE, BIM standards. That's underway now. The PIR, which is Project Information Requirements, Digital Engineering Execution Plan, Model Production Delivery Table, Master Information Delivery Plan. So there's 4 documents there, huge acronyms. We've got a whole bunch of supporting templates, but we're bringing them into alignment with a focus on the New South Wales infrastructure, digitalisation and data policy. So aligning with also aligning with ISO 19650. So we're planning what the new changes are. So ISO 19650 is being updated. The first three documents, standards being updated towards the end of this year. So we're across what's happening there. And then also our evolving MMC DFMA delivery model. So working closely with the builders that are producing our schools. We've got a couple of key projects underway at the moment with the preschools delivery. That's all very MMC DFMA focused. So these are not just document updates, they are digital engineering backbone to how SI projects are designed and delivered. On automation, we've implemented a dedicated BIM management platform. It manages our DE standards, the documents I mentioned earlier, but also enables verification and automates the checking of information requirements. So that's a major sort of common environment for us, that platform, of which we make accessible to all of our delivery teams. And that shifts us away from manual compliance checks to automated verification, which is essential for what we do. We're managing the digital delivery for a large number of projects. On integration, we're developing a connection between BIM models that are hosted on our common data environment and the DOE digital twin. So this is a project that's been around for a little while at the moment, but we've got some work being done currently within AM, within our asset management team, that's looking at reigniting that, because there's a lot of work done on that platform, and it's certainly going to be a very useful tool. It's integrated with the New South Wales spatial digital twin layers, so we can consume those layers for reference. The goal is that information created during design and construction workflows, and that seamlessly feeds into the operation systems. So that asset information model has genuine value for us. And we need to make sure that has value from day one for all of our asset management staff, which make up the major part of SI.
And in addition to the innovation that we can drive from the immediately digital point of view, there is also other aspects like the modern method of construction, MMC, or design for manufacturing assembly, often referred as a DFMA. How do you think that these two approaches change the way schools are designed and delivered today?
Oh yeah, I mean, MMC and DFMA fundamental re-architecture of how we think about school design. Traditional procurement treats each school as a bespoke project with a unique design developed from scratch. MMC reframes that a school as an assembly, or of standardised, pre-engineered, digitally defined components, whether we talk about it in the terms of kit parts, or now we talk about it as part of our pattern book content. That has evolved through engagement with industry, and when it comes to then actually delivering the schools, they know that our preferred way to deliver those schools is MMC DFMA. It provides us with the opportunities of minimising site time, de-risking safety issues where these kit parts or standardised assemblies are manufactured off-site, delivered to site for assembly. So that's fundamental to modern delivery now of schools in New South Wales. From a digital engineering perspective, it's transformative. When components are pre-engineered and pre-specified, the BIM model for a new school can be largely assembled from a library, a validated library. The LOI compliant program components. So pattern book is preloaded with our information requirements, if you like, or the parameter placeholders. So information requirements are ready to be received. Dramatically reduces design time, improves model quality and consistency, creates a much richer foundation for the asset information model. So DFMA manufacturers, say in factory environment, assembling on site, also creates that direct digital thread from design to manufacture to delivery. Factory produced components can be manufactured to tighter tolerances, and that gives us a better on-site construction. That means that as-built reality more closely matches the design model. So that also becomes much easier to manage that process of capturing as-built information. In practical terms, SI has demonstrated that DFMA can reduce the on-site construction assembly time by up to 30%. So reduce carbon emissions is something else we're looking at, and the material waste by more than 30% reduction. So creating, really, as far as the environmental side is concerned, improving that and creating those safer work environments. So it's a proven efficiency and quality gain.
Definitely. And I'd like to change gear and start thinking about the future. It's very hard to predict the future. Nobody probably really can. And I know this may be a hard question about to ask, but how do you see the digital delivery evolving over the next, let's say, 5 to 10 years?
Let's see. It is a good question. I suppose when you look at digital delivery today, what it looks like across the infrastructure in New South Wales today, for the first time, if I go back to the IDD policy by New South Wales, this is a real jump. For the first time, we got a New South Wales government infrastructure agencies have a unified mandatory approach. So that is new. But it's been talked about for a long time. So that policy will really have an impact. I see that as really having an impact on what we're doing. As far as technology, you can't ignore AI. We certainly investigate AI, but at the same time, you have to. There's a lot of, I suppose, news in the open arena about security issues and the like, and so we need to be really careful as a government agency. So we can test those environments in an external environment, so it doesn't got no way of impacting our own infrastructure. But that gives us the opportunity to investigate those opportunities with AI, and we have done some simple tests and some more in-depth tests, and have very interesting results in those. So as far as the big changer for the industry going forward is that use of AI, but it needs to be understood more. It's we've gone at the days when it's only been around a short time, really. But gone are the days where you just jump into even your browser's AI assisted now, anyway. But everyone's probably gone in to use ChatGPT or whatever for whatever they're looking to do as far as producing reports or reviewing emails or anything like that type of thing. We need to get way beyond that because there's a lot better uses of AI. So it needs to be structured and governed. So there's a bit of an issue there. From our point of view, our focus is around what drives delivery of schools to respond to the requirements, the school requirements for our students across the state. So the way we've been delivering that at the moment is, and way we can improve further the delivery of that is through our standards and guidelines, our pattern book, and our standards, our digital standards, to streamline and provide a more efficient way of delivering. But yeah, AI is coming.
Yeah, definitely. Yeah, it's tricky because you have to manage keeping the standard, making sure that it is safe to use it, and at the same time driving innovation. It's hard.
Yeah, but we see different areas of innovation in the construction sector as well, which have the sort of largest impact on what we're doing. So the whole adoption of modern methods of construction, what comes out of that growth in MMC and DFMA approach is also driving some real efficiencies and development in that space. Often overshone by the fact that there's this new AI thing that people are doing on computers and whatever. When you look at the environments we create and the improvements that are made in the construction, that is significant. So we're still very much focused on that.
Definitely. And you've been a leader in this industry for a while now, and you have probably seen other people having different leadership styles. From your point of view, what does effective leadership looks like in digital engineering?
Yeah, it's I suppose it requires a combination of attributes that don't always coexist naturally. I've been fortunate in that I've worked across a whole range of industries, and I think people in my era and have probably done that as well. But certainly that deep technical credibility. I've worked across a whole range of different systems: GIS, CAD, BIM, around information management, storage of huge data structures around Oracle Spatial, and in the past which we drove on the I-21 project. So that technical credibility, strategic vision, communication skill, being able to communicate about it, and genuine patience with the pace of organisational change. So be patient. Typically in that digital environment, we can change rapidly. So it's really important to stay patient with a whole organisation change. People will go, if you give them a good direction, they will follow, but they'll follow at different rates. Technical credibility matters because digital engineering is a field where practitioners can quickly identify leaders who are speaking theoretically rather than from experience. You need to have done the work to really understand it. You may have written an EIR, managed a accommodated environment, resolved a clash, debugged a model, whatever it might be. Without that sort of experience foundation, your strategic vision lacks credibility. Technical credibility alone is insufficient. Leaders who create lasting change in digital engineering are those that can translate that technical capability into organisational value, who can explain to a CEO or Director General why ISO 19650 is significant. We need to be compliant. Is an organisational capability investment, not just a technical compliance exercise. Perhaps most importantly, from effective DE leadership requires the ability to build and sustain coalitions, relationships. Digital transformation doesn't happen through mandates alone. It happens when people across an organisation, that's what's such a really good experience, as it's such a joy to work in school infrastructure, where you've got design managers, project directors, facility managers, procurement officers, IT leaders, all understanding the purpose of digital engineering at different levels, but they're genuinely invested in making all of these systems work. So we recently rolled out an update to our integrated operating model. And it's really bringing the teams together. So, it's good to see it actually happening. at this level in the sort of public environment.
Definitely. And there are lots of people that are probably just starting now, they're young professionals, they're just starting in this space, or maybe they are looking to transition into this space of digital engineering. What advice would you give to professionals looking to build a career in this digital construction space?
Well, certainly, build those sort of technical foundations properly. Understand how information is created, structured, and used across the asset life cycle. So, get hands-on experience. The BIM tools, common data environments, information management workflows, not just conceptually, but operationally. Second, develop information management literacy, understanding ISO 19650. That's now the international standard for BIM information management. Understand it, get it certified. There's lots of great courses out there, and I'd encourage anybody to really do that as well. It's the professional common language of our field, and that sort of proficiency in it will differentiate you in the labour market. Further investment in communication skills, being able to talk technically, and be able to get that message over and clear to the people that you're talking to that they won't have a digital background. So most technically capable digital engineers I've worked with certainly are often not necessarily the most influential, because they can't translate the information into a language that sort of resonates with non-technical stakeholders. The ability to explain the business value of a common data environment to a CFO, or the community impact of a DFMA school to a local councillor, is as important as knowing how to configure the common data environment. So it is a broad knowledge, but certainly, don't be fazed by it. If coming into this, this is a great industry to be involved in. So do the technical foundations, understanding the key standards that drive our business, and learn them. And stay curious as well. Field is evolving fast. As you said earlier, who knows where AI will take us. That structured curriculum can sort of track what you're doing. Professionals who will lead in 10 years are those that are actively engaged in emerging technologies. You're probably the same as I am, that you might switch your computer off at 5 o'clock, but it doesn't change your thought process, and keeping your eye on the industry at all times of what's going on. It's evolving fast. Professionals will lead, are those that actively engage in those technologies. AI, digital twins, generative design, automated compliance checking. At least that one I can tick off. The other one, digital twin, we're getting there as well.
We are at the end of the episode, John, and thanks for that, because it doesn't happen often we get to speak with somebody in your role. If people want to reach out to you, where can they find you?
Yeah, find me on LinkedIn, or reach out to Department of Education. I'm more than happy to contact with anyone. So that's the easiest way. Is I think we're all on LinkedIn now. So reach out there. I certainly communicate with a lot of different support groups, etc., in that environment. So it's probably the best method.
John, thanks for joining us on the Digital Construction Podcast.
No problem. Thank you very much. It's been been a really good experience. Thank you very much.